So now that we've explored all these different types, we've explored the syntax. How do we actually convert between data types, right? Sometimes we need to turn maybe a char into a string, or a string into a char, or an int into a double, or a double into an int, and so forth. Sometimes we need to modify between types, right? So we do this via casting. So what is typecasting? It's the process of converting one data type into another. So it helps you convert variables to compatible types, ensuring that operations can be performed properly between different data types. So there are two types of casting. There's implicit casting. That's when Java automatically does it for you. So like I said, even though Java is strongly typed, sometimes it can make guesses. It can imply the types that you're switching back and forth between two. So implicit casting is really useful because it's going to save you the stress, right, of having to do the casting yourself. Um, a lot of the time, you will have to do explicit casting. That's when you manually convert between different data types. There is a syntax to it, which we'll explore in some of the next slides. So be careful. Sorry, be careful when you're casting. Explicit casting can sometimes cause loss in data when converting between disparate types, and not all casting is possible. So you can't just cast between all sorts of different types. There are limits to it. We're not going to explore all the different limits. We're just going to go through some of the common implicit casting and just a couple examples of explicit casting. So here's an example of explicit casting from a double to an int. So we have our int num1 is equal to 50. We have a double type variable called num2 equal to 30.75. So let's say we set our a new variable set to the same value of num1. So it's saying, hey, result 1, I want you to point to whatever num1 is pointing to. So we're going to go to num1 and we're going to see, okay, it's pointing to 50. So now result 1 is equal to 50. Now notice, we made result a new data type. We made it a double. The cool thing about Java, it's going to do implicit casting. Because these are two number types, it's going to just imply that, hey, I'm going to turn this 50 and turn it into a decimal. You could also do explicit casting. So for example, let's say result2 is a new variable, and we're going to turn num2, which is a double, we're going to turn it into an int. Notice the syntax for explicit casting. You declare your variable. If you are doing a declaration, you don't always have to declare when you're doing casting. You can throw it in in a method or whatever the case may be. This will make more sense. We're going to do this more in some later programs. We're kind of just introducing it now. We're easing into it. But what I want you to focus on is the syntax on the right. If I want to turn num2, which is a double, we declared it as a double, into an int, all I have to do is parentheses int in front of the variable here. And that's going to cast num2 as an int. Now let's see what happens when I do that casting. Well, when I print out result 1, which was turning the number 50 an int into a double, it's going to output the number 50.0. Even though num1 was just 50, as soon as you turn it into a decimal or a double, it's going to add the 0.0 in there because doubles are decimals. Now, we didn't really lose any data here because we're adding decimal places that were not there, and we're adding a 0 decimal place, right? So that's not really changing the value of the 50. If you do math on this number, it's going to be identical. Now, in the case of a double into an int, which is result 2, right? We turned num2, which was a double of 30.75. We turned it into a whole number, integer. We casted it. It's going to cut off the decimal. So this would be an example of data loss. So it was originally 30.75, but if you turn it into an int is a whole number. An int doesn't have decimals. So it's got to chop off the 0.75. And again, that would be an example of data loss. Let's look at int to a float and then int to a double. So again, another example. So let's say we have the number num1 is equal to 100. So this one might be a little bit easier to follow than the last one. The last one might be a little complicated. That's okay if you don't get it. Again, we're going to do this more in depth in some of the later lessons. Just understand the basics. Casting means converting, and then notice the syntax here. All right, so we're going to turn this num1 into a float and into a double. We did them both by implicit casting because we didn't do the explicit parentheses, right? So we're letting Java take the wheel and, hey, figure it out. You do the casting for me. Because it was originally an integer, when I print out the integer, it's just going to be 100. Now, when I print out the num2 and the result is a double, num2 is a float, then it's going to add the decimal at the end because of the implicit casting. Again, cool thing about implicit casting is I don't have to go in there and do that parentheses float or parentheses float or parentheses double. Java does it for me automatically. So it can be really useful, can help you avoid some errors. Back when I was first programming, I would just cast the heck out of everything just because I was worried about when it would not be implicitly casted. But if you know your implicit versus explicit casting, then you can save yourself the trouble of explicitly casting everything. So a really common example of implicit casting is concatenation. It's the process of joining two or more strings together into a single new string. In Java, concatenation is commonly used with the plus operator. So if you want to combine different strings together, or even strings and numbers, little clue there, it's going to be implicit, then you use the plus operator. That was like in the case, if we go way, way back on why we use variables. Let me go back here. Notice this is concatenation. We added a string, we added the name, which is also a string, and then we add the exclamation point at the end, which is also a really short string, but still a string. So that's an example of concatenation that we showed early on. So it's when there are cases where some of the things you're adding together or concatenating are not all strings. So you can concatenate a string, for example, with an int. The cool thing about concatenation is that Java will automatically convert all the other operands or all the other things that you're adding together or combining into strings. So when you do concatenation, it's going to be implicitly casted every single time. So this implicit casting is very helpful when you're printing out variables to the console using the built-in system.out.println method in Java, or system.out.print, depending on which one you're using. So yeah, when you're doing concatenation inside this method, it's going to automatically do implicit casting. So it's going to save you the trouble of explicitly casting everything into a string, because this method only handles strings. You're only supposed to put strings into this method. But because of the implicit casting of concatenation, it's going to turn everything automatically into a string. So Java saves you that headache and saves you those type errors. So again, even though strongly typed, these implicit casting gives you a lot of exceptions, and it saves you some of those headaches, right, of having to do it yourself. So let's look at an example of concatenation and implicit casting of an int to a string. So I want to print out the number 100 here, int num. So num is the name of the variable. So when I do string result is equal to text plus num, that means I'm concatenating the number is and 100. Even though these are disparate data types, they're different data types. We shouldn't be able to do this in a strongly typed language, but Java is giving that implicit casting in concatenation. So saying, hey, I know, you're just trying to print this out. You're just trying to print out this message. I'm going to do the casting for you. So the int is automatically converted to a string in this case. So when you print it out all together, it's going to print out successfully. It's not going to give you a type error. One of the beautiful things about Java is the implicit casting. So type language is really useful, right? Because you're making those promises so that you avoid problems in the future of your program where you have incompatible data types. But the implicit casting saves you that tedious work, right, of having to cast every single thing every time you're trying to combine different types. So these cases of implicit casting can save you a lot of work. There's an interesting casting, and that's with chars. So char can be cast to an int because characters in Java are internally represented as Unicode values. What is Unicode? We'll talk about that in the next slides. I know I promised it early on when we talked about char and introduced that as a primitive data type. We're now going to actually explain why you can convert a char into numbers, whole numbers specifically. Well, Unicode values are numeric codes assigned to characters. The characters on your keyboard each have a numeric value that represents them. Since Unicode characters are represented as numbers internally, a chart can be implicitly or explicitly cast to an int to obtain its Unicode value. So let's take the char letter of A, the uppercase A. If you do an implicit casting where you just throw it as an int in this variable declaration, you're saying, hey, assign the value of letter, which is the letter A, into this int Unicode value, Java's going to say, I got you. I know what you're doing. And when you print out the value, right, to test out, hey, what's inside of Unicode value, it's going to output 65. Because that is the number in the Unicode table. It's a table of values that represents the uppercase A. You could also do explicit casting, and it'll have the same effect. It'll print out 65, because 65 is the number that represents the uppercase A. So here are some selections of the Unicode table. It's a massive table, so I can't show you all of it. You can click on this link to see the whole table. But here's some portions of just like the Latin part of the table. Notice the backspace has a Unicode value. The null value, that's like no value, that has a Unicode value of 0. The start of text, even things that you can't see, right? Those have Unicode values. Because the programming, the language, the compiler actually can see those values, can see a backspace, can see a new line, can see a tab, can see all those things. But some things that we can see, right, like letters and symbols, you can kind of see the ampersand here at the top. Or is it the at symbol? I forget. I need to double check that. But yeah, these uppercase letters, for example, they all have a Unicode value, a decimal value, a numeric value that represents them. So the uppercase A is represented by 65, the uppercase G by 71, and so on and so forth. You can check out all the values here in the Unicode table. Just navigate to the basic Latin section if you want to see some of the, the commonly used symbols that you use in your everyday life. So that's it for this lesson. Next up, we'll cover the lab.